Alrighty, so we're live. That's great. Hi everyone, welcome to session 2 of the QGIS Open Day. Thanks all for joining us again for our next plugin session. I hope you all saw that there's been an update to the roster. At the very end of the day, Tim is going to have a town hall meeting where we can all discuss the new release of QGIS. So I think that'll be great. There's a open Jitsi link, so if you want to join in us in the room, that would be great. Alrighty, so on to session 2. So our session is going to be on the plugin called OSWalk EU or U. And it's a walkability plugin. At the moment, it's experimental. Of what I can understand, it's an experimental plugin. And it's all about walkability in neighborhoods and being able to plan infrastructure. So I'm going to hand us over or put us into the capable hands of Christian. He's going to take us through this awesome plugin. So over to you.
Yeah, thanks, Amy. Let me share my screen. Hope that's the right one.
I'll let you know if I can see it. Yes, perfect. It's a presentation. Okay. Great.
Okay, then let me have a short look to see my screen. Yeah, perfect. Yeah, hi everyone. My name is Christian. I'm researcher at the ILS, the Institute for Regional and Urban Development in Dortmund, Germany. And I'm working in the section of geoinformation and monitoring. Today I would like to present our walkability assessment tool, the OSWalkU tool it's called. And yeah, I'm the developer of this plugin, but I'm just a spatial planner with some experience in programming and tool development. I got a lot of help from our former geoinformatics student assistants and our technical staff at ILS. So my presentation is more about showing the methodology behind the tool, and I will go also a little more into detail about how to run the tool. So I will present a short live demo. Okay, let me tell you about a short introduction about the genesis of the tool and why those walkability assessments tools are important for us. So the ILS deals with important topics of sustainable urban development, and one of these topics is, of course, mobility. Walking has a positive impact on the environment, also the social behavior and the health of urban residents. And so it's one challenge of the cities in the 21st century to improve the walkability. To measure this, there's a need of walkability assessment tools. And currently there are a lot of walkability assessments tools. For example, the Walk Score, maybe a few of us will know it, or the IPAN walkability. But often we've seen that's not sufficient for our research. And therefore we decided to build up our own walkability tool, OSWalkU, which is based on open source and open data, so that everybody can run the tool by their own. And yeah, it was a collaboration together with colleagues from University of Lisbon and TU Dublin. So we worked together on the methodology, but the programming part was more part of the ILS. So the tool, OSWalkU, it stands for Open Source Walkability Tool for European Union Member States. So we can calculate walkability for neighborhoods or complete cities for Union Member States. And yeah, currently it's published as experimental plugin. So it's an early beta version of the tool. Yeah, maybe it's a little bit too early to present it here, but we thought it would be a good idea to get some feedback from the experts in the audience. And yeah. The code is not very complex. It just uses native QGIS algorithm and also a cool tool called OpenRouteService, with which we can calculate pedestrian network analysis. And yeah, currently it's available via GitLab or the QGIS repository under the experimental plugins. Yeah, now I'd like to go more into detail about the components and the dimensions of walkability, which we consider. In total, it's 5 different components which influence the walkability in a neighborhood. First of all, the pedestrian network, very basic. Also the slope, population density, the green infrastructure, and the supply with amenities or important infrastructures. This is a short or a screenshot of the GUI or the user interface of the tool. So just to show you some minor stuff. Later we will see it a little bit better in the live demo. On the first tab, we have to set the parameters of the tool, for example, the input grid or input geometry, for which we would like to calculate the walkability. We suggest to use input grids, especially from the Eurostat, because there is also information about population, which we need, for example, to calculate the population density. Second, we need the recreational areas to calculate the green infrastructure. He would suggest to use, for example, OSM, the OSM land use, or Copernicus products like Atlas or something else. Further, we need amenities, so the location of important infrastructures. I think here it's important to use, for example, the data from OSM. I think the PRIs are very quite good for it. And last but not least, also the DEM, so the elevation model here as raster. This is important to calculate the slope in this area. On the second tab, the user can refine the analysis. So we allow the user to set different weightings on the variety of infrastructure, for example. The infrastructure is not very easy to understand now. I will explain later because it's not that easy. But also the user can set the weighting of the different dimensions of walkability. For example, the amenities, the pedestrian shed, and population density. You can set different weightings, what is important for the user. What is the basic idea behind the tool? Our idea is to evaluate the walkability in the direct residential environment, to rate the residential walkability. This is defined in the tool as a walking distance or maximum walking distance. This could be set by the user. We use a default value of 500 meters. You can see it on the right side. So it's 500 meters over the street network as a pedestrian. And mostly all of our indicators are calculated for this area or this walking polygon. As you maybe see, slope is one of our dimensions in walkability, but it was not part of the GUI, so we can't set a weighting for the slope. This is because we thought that it's not that important to be an own dimension of walkability, but it also influences the walkability. So we say it could reduce. It's optional to set in the plugin. It could reduce the walking radius based on a simplified hiking function you can see below. So, for example, if we have in the neighborhood on the right side, we have a slope of 30%, the maximum walking distance or the default value of 500 meters would decrease to 300 meters. So it gets reduced. Our first indicator or first dimension, first component is the pedestrian network, short we call it PN. That's very important because the directness of routes and the permeability of a street network is important for walking attractiveness. So it's basic for walking. And here we use an indicator called pedestrian shed. On the right side, you can see now that we have our walking radius in orange here. With 500 meters, and we set this polygon in relation to a static buffer of 500 meters, which for us represent the perfect pedestrian network. And it's just a normal coverage analysis, and the value could therefore range from 0 to 100, whereas 100 is a perfect walking polygon. For all our indicators, so for the pedestrian network, for the density, the green infrastructure, and the amenities, we did a reclassification of the values. For example, in this case, we have a range from 1 to 100% or from 0 to 100%. And we classify these values from 1 to 10, as it's more easier to understand lately at which point it is a good value, and that we compare the different dimensions of walkability. So we did this reclassification for all indicators. Here I have some examples of how the built environment could influence those walking distances or the direct residential environment. Here's 3 examples of residential areas in Dortmund. The first one has no barriers in the direct residential environment, or no bigger barriers. Or one example you see is one in the north, but it's mainly outside the polygon. So you can see in the first example that the walking polygon here in red and the aesthetic buffer is nearly the same. So we have a very high pedestrian shed here of, I would say, around about 90% or something. Second example represents some semi-permeable barriers. We are here near to the central station in Dortmund. But here we can see that there are some minor sneaky ways throughout the tracks and the train station. So the walking polygon is quite good, or the pedestrian shed is quite good, with the value about 70% it was. The last example shows some impermeable barriers. On the south, you can see a highway which is not traversable for pedestrians. On the eastern side, you can see a track, and on the eastern side, you can see the green place, a cemetery where we do not have direct access. So the access to this green space is on the northern part. So we have a very small walking area, which is about 15% or 20% pedestrian shed. So our next indicator is the population density. This indicator was mainly used in older walkability assessment tools, like in the IPAN walkability, which was developed end 90s, beginning of 2000s, I think. And they use it because they don't have any information about infrastructure or no good data for infrastructure. So they say, okay, high population density indicates a high coverage of infrastructure supply. But we live in times of Google Maps and also an increasing and great OSM quality. So actually, we don't need this indicator for this purpose. But also many research shows that the high density allow more social contacts. So the people, when you live in a very dense neighborhood, you have more options to meet people outside, for example. And this is also an increasing factor for walkability. Actually, here we classified the values in deciles, as we do not know at which point, at which density the social contacts or social contacts could increase. So we say, okay, we classify this into deciles. So 10% of the cells with the highest population density gets 10 points, up to the lowest 10% get just 1 point. This is a problem because if you just calculate, for example, the walkability for just 5 or 6 cells in an area, then it could get a problem. Then we need to say, okay, this indicator should be weighted with 0. That does not influence the walkability here. But I can show you an example later on that. The next dimension is the green infrastructure, as this increases the attractiveness of residential environment and also increases and attract active mobility. As you all know, if you have green space outside, you're more likely to walk, and it also increases social interaction. So if you have a green space outside, you can meet people, for example, and in total, this creates a healthy environment and also better living conditions. For this indicator, we did also some kind of coverage analysis. So how much percent of the direct residential environment consists of green and blue infrastructure. And so here the results could also be from 0 to 100. But here we say, okay, it's not that important to have, for example, 100% green percentage. It wouldn't be get good because there's no space for residential and other amenities. So we can say, okay, at a maximum of 22.5%, there is no benefit of having more green space. So we say then we have 10 points, and in 2.5 steps, we go down to just 1 point by less than 2.5% of green infrastructure within the polygon. Yeah, the last indicator, and for many assessments tools, the most important one is the supply with important infrastructures. Here short distances are very important on factor and affect the walkability. as it's very clear that if you have a supermarket which is 200 meters away, it's okay for walking and get the supplies there. But if it's, I don't know, 2 kilometers away, maybe you need a car or other mobility options to get there. Here we mainly use the walk score methodology, but in our case, the user can select the variety and weightings of the amenities by their own. So, and also we say that closer facilities are more attractive than facilities which are in a longer distance. This fact is reflected by our distance decay function we use here. It's an adapted cumulative Gaussian function. You can see the distance in meter and the distance weighting. So we say within 400 meters, it doesn't influence the attractiveness of an infrastructure, but then the curve decreases. So for example, if we have a distance of 1 kilometer or 1,000 meter, the distance rating would be 0.5. So not that attractive as, for example, an infrastructure which is 200 meters away. To make it more clear, I give a short example here with two infrastructures. We have first a supermarket here in red with a weighting of 5. So we weight this infrastructure with 5 points as it is very important and everybody needs it 2 or 3 times a week. Here we have a distance, or the shortest distance to the supermarket is 574 meters. And the other one is a pharmacy in the north, which is also important, but not that often. People need to do, I don't know, a few times a month or something. So we weighted this with 2 points. And this infrastructure is 759 meters away. Now we can take our distance decay function and drop on the weightings here, or the distance here. So for the supermarket, we have around about 570 meters, and the weighted distance would be 0.94. So it's quite very good value. For example, for the pharmacy, it wouldn't be that good. It would be 0.77. In total now, we calculate the total points for example, for the supermarket. Here we multiply the infrastructure weighting of 5 by the distance weighting. It's 0.94 and a final value of 4.7. Do the same for the pharmacy, which results in a total value of 1.54. Here we can see that the sum would be 6.2, where the maximum would be 7. So if both infrastructures would be in the distance of 400 meters, would be the maximum value. In this case, it's very easy to understand in which range the value could lie. But if you have more infrastructures and more varieties, so if you say, okay, I look for 2 supermarkets and 2 doctors also around, it would be very confusing. So we decided to transform the values from range to 0 to 100, so that the user can easily understand in which range the values could lie and how to interpret the results. So in this case, we multiply with a correction factor of 14.3. So the maximum value would be 100, and in our cases, in our easy or simplified case, it would be 89.1, the total result. But in our case, we look at some more categories or some more infrastructures. In total, we consider 6 different categories of infrastructures, which are derived from literature and also were discussed with our colleagues from Dublin and Lisbon. Here you can see, for example, the retail category, which includes clothes, optician, books, for example, entertainment, like theater, cinema, art center, food-related stuff which is very important, supermarkets, marketplace, or restaurants, civic and institutional facilities like college, community center, schools, but also healthy stuff, and office, which includes company and consulting, for example, and last but not least, the recreation spots like fitness sports center or swimming pools. Here we did also reclassification of values. So we say, we classify it into 10-point classes from 100 to 1. Here we need to pay attention that the POIs from OSL, for example, is categorized the right way. So we need, for our tool, we need a new field called type, where we said, okay, fast food is reclassified or is classified as food-related stuff. Nightclub is, for example, entertainment. And so we provide some kind of translation table for that, but the user is also free to do it by their own, to say, okay, for example, for infrastructures like bar, that's very complicated. It's food related or is it more entertainment? So in total, the user can decide by their own how to classify those categories. Okay, now that we have all our 4 indicators calculated, we need to sum up all the points. So here we multiply the points that we have, for example, for the pedestrian network, we multiply this value by the weighting that we set in the GUI, and that we do it for all or 4 indicators. And then we have a value range which is not very clear, as the user can set the weightings by their own. So we're also transforming the values from the range from 0 to 100. Let me show it in a short example. I think it would be much easier to understand. For example, if we have a pedestrian chat of 75, we get 8 points, density 7 points, green infrastructure 5 points, and amenity 9 points. Then you can see there's a screenshot from the GUI where we set the weightings of the amenities, waiting for the dimensions. For example, amenities in pedestrian chat get the full weight, population density 0.5 points or weighting, and green infrastructure also 0.8. Now we can fill in all the information that we have. So we multiply the pedestrian chat 8 by the factor 1, the weighting 1. The density is multiplied by 0.5, and so on, that we have a total value of 24.5. It's not very clear now in which range this value is, and therefore we transform it to make it more understandable. So we have 24.5 multiplied by 100 divided by 33. This is the maximum value that we can get if all the facilities would lie in a distance of 400 meters, for example, and we have the highest value overall. So in total, we have a value, a walkability score of 74.2. This is an example of complete calculation for a city, Stuttgart in Germany. It's calculated on 500 meter grids, I think. And we also classified these values from very low walkable areas, so values up to 30, to very high walkable areas in 75 and more. So you can see here in green the very urban areas in the city center, which are quite high walkable. Also, some suburbs are very walkable, and in the outskirts, more rural areas in Stuttgart, you have very low walkability areas. So we would say for these areas that values up to 45 are more like, would say, car-dependent areas or car-dependent neighborhoods, which are not very walkable. And their values above 45 are more likely walkable neighborhoods, would say. We can also calculate total scores for all cities. For example, for Stuttgart, it would be around about 60, walkability score of 60. For Berlin, for example, it would be, we calculated is 58. And Dortmund, not that good, 45 walkability score. Yeah, and let's go into a short live demo of the tool. Let me share my screen again.
Alrighty. Live demo, I'm ready. Just as you go over to your QGIS live demo, we do have 2 questions, and I think they may be answered in your demo. But the first one is from Miguel, and he asks, does the plugin get the amenities automatically?
No, currently not. We plan some kind of pre-processing. It would be very good if we have it. But at the moment, you have to download the POIs by your own and classify it by your own. That is something, it depends on, do you want to have more freedom for the user or to make it more easy for the user? But I think it would be a good option to have that the plugin takes all the POIs and classify it by their own and then calculate it.
Fantastic, fantastic. I think let's head on over to your live demo, and Jan, we'll answer your question at the end. I think it's a more sort of open-ended question, so we'll get to you then.
Okay, so then I share my second screen. I hope it's visible.
Yeah, I can see.
Okay, perfect. So now we are in QGIS. Within our master branch, we have also some sample data to calculate, which are quite here. So sample POIs, a sample grid with also the information about the population in it. We have some sample green areas here and also the DEM, which is not very interesting for Dortmund because it's very flat here. Okay, then we could start, or you also can see the classification of the POIs. And yeah, what is important is that you have the OpenRouteService installed and also set an API key for the calculation of the pedestrian distances here. That's quite important. It's also part of our wiki, which hopefully we will publish at the end of the year. And currently we have some problems with our icon also, but here you can start the Walkability plugin. Okay, here we have an input grid, which is our sample grid with the field called population here. We have some sample green here, the POIs, which are classified. I can show it before I could ask the question here. So here all our F classes are classified, for example, florist is retail, supermarket, food related, and so on. So we need this field type that the tool knows, okay, how to classify, how do I have to classify this F class. Okay, oh no, I started the tool, but it's not a problem. I can also, oh no, it's some kind of crashing. No, don't. It calculates automatically. I restarted, but it should be a problem. Okay, the sample POIs. Here you can set the maximum walking distance. Here we said, okay, maximum is 2.5 kilometers at the moment, and minimum is 250 meters. And also the digital elevation model to calculate the slope. So it's optional for us, but yeah, we can let it in here. So here we can set out, now refine our analysis by set the variety and the weighting of the infrastructures. So we can say, okay, how many retail facilities I need? Did I need 3 or 2 or 3? In my case, I would say I need 3. And I can weight the different infrastructures. So the nearest one, it's important for me, it gets 3 points. Second and third are not so important, I just get 1 point. And so I can do it for every category of infrastructures. Currently, we have a maximum count of 3. We also plan to make it more accessible here, but currently it's a test version of our plugin. We also can set food and drinks and so on. Office we set with 0, and here below you can set the weighting of the dimensions of walkability. I say amenities are very important for me. Just get 1. Pedestrian chat, also very good, 0.9. And yeah, if you say, okay, population density is not important for me, we would like to exclude it from the analysis, and we set it to 0. Then we said, okay, just create a new folder, test calculation, select, calculate. Now the walkability process starts, and hopefully it doesn't take so long. Yeah, perfect. So now we have our result. We can have a look on the table now. So the information population was inside before. What we have new is we have a new ID, which we need for our calculation, but then it gets interesting. We have our total amenity points, so our some kind of walk score here. We have the reclassified points, so here will be 3. So we have 24 points in the amenity calculation. We have the population density with the deciles. We have the pedestrian shed also classified, the green percentage in points, and last but not least, our result, which we could map here. So we can say graduate result. Let's take it green to make it look good. And here we can see, okay, we have this classification. Let's have a look on the base map to see where this is. It's a place in Dortmund, our sample data set. And we can see here that these two areas are the best one in this calculation step. So we say, okay, these are the most urban one. These the other one like between in some industrial and commercial areas, also some tracks here. So this, I would say, makes sense that here the walkability is the best. I brought some more interesting examples. So this calculation took along. So we have here an example of Dortmund also on 200-meter grid. Here it took, I think, about 2 hours or 3 hours to calculate it. So currently it's not very performant to run this tool with large data set. But here we can also say, okay, here we have our walkability score result, and you see in the inner city center it's quite good. In the rural areas below, where we don't have any or not a good supply with infrastructures, it's quite bad. And we can see some suburbs which also have a good supply with infrastructures, but also some green areas and pedestrian network. What we can also do here is to display, for example, the indicators here. For example, the pedestrian chat. You can see, okay, where's the best street pedestrian network? You can see, for example, in the inner city center, it's quite good, as there is the most people walking there and or the most ways for pedestrians. And in the southern parts, it's not very good, and it could be better, I would say. Yeah, I think that's all from my part. Let me get back to my presentation. There's 2 more slides, I think.
Alrighty, while you hop over to your presentation, Jan just asked how much time, you mentioned that it takes some time to obviously run the larger data sets. Mm-hmm. So how much time did it need for you to run the tool, for example, for Stuttgart?
Well, I think it would take 2 hours for example, 200-meter grid. It's not very performant at the moment, but hopefully you can see my presentation now.
Not yet.
Let me show. Here. Sorry, the right one. Yeah, now.
There we go.
Yeah, I come back to the major improvements that we have, or what we would like to make better. That's also the case of the performance. So we are planning to head to an alpha version beginning of next year. It's some kind of resources that we need to improve that tool, but yeah. Some minor changes like simplify the code. We have some redundant parts in it that we need to improve. Improve also the GUI look. At the moment, it doesn't look very good. It's needs some time to make it look better. And yeah, current challenges. I think that's the most important one. We need to increase the performance, as currently we can't calculate the closest facility or amenity at the moment. So we say, for example, in our tool, you can say, okay, I need the three nearest facility, but the ORS has not this function. So currently we need to calculate the distance metrics. So from the point to all amenities in this area. And that's quite of resource. It took a lot of resources to calculate it. And the next problem is that we have, or the OS does provide just a limited request per day. So limited token, I would say. So normally the user wouldn't be able to calculate a whole city because it would be out of range, out of the free requests per day. We have installed an own version of the ORS at our server, so this works good. But I think not everybody can do this. So our plan is to simplify our distance weighting function. So we do not need to calculate the direct distance, that we make it more like looking for steps. So simplify the function and then simplify the code in just using the native QGIS algorithm function count point and polygon. It would be very easy to calculate it, just to calculate some more travel time rings or walking rings. I think it would make it much easier, much more better performance for it. And yeah, some more ideas are for us to define profile settings, for example, for elderly people, that we say, okay, elderly people do not walk such long distances. They need other infrastructures, that we could define profile settings also for younger people. And another idea is to integrate, for example, public transport data from GTFS files like frequencies or transport type to identify car-dependent areas, or really car-dependent areas. As I showed in Stuttgart, we define the lowest categories of walkability as car-dependent areas, but totally we don't know, because we do not have information about other mobility options like public transport, and that would make it more easy to see the structure, the mobility structure of a city. But that would be more kind of another branch of the tool. So maybe a second tool would could derive from that. Okay, some kind of last conclusion. We are at the early stage of development, I would say. And maybe it's not that easy to follow the methodology. Therefore, we prepare a wiki with detailed information about the calculations and so on. And yeah, we also plan to publish a scientific paper, or we also wrote the paper and get a review for it, and hopefully it will be published end of the year or beginning of next year, which is also could be some good reference to understand the methodology behind the tool. And yeah, as I say, an updated version of the tool at the beginning of next year, hopefully. And yeah, if you have any ideas, questions, critique, or ideas for collaboration, please ask or contact me, also by mail. And yeah. Also, you can see some our WebGRS, which is our city region monitoring, but it's just in German, so maybe not interesting for us, but it provides some nice maps, and we also include our walkability indicator in it. So if you want to have a look on it, just go to the website, and yeah, if you have any question, ask. And yeah, thanks for having me.
Brilliant stuff. Thank you so much, and thank you for those contact details. I think this is such a fantastic plugin, and it's got so much possibilities, and is very, very usable for, infrastructure planning and infrastructure use. I think one of the main questions I had at the sort of very beginning, when you mentioned that it's mainly for European countries, is there a plan to expand into other countries, or is the application able to apply to other regions?
Currently, it's possible to calculate for every city. You just need the data sets. So, for example, if you have a digital elevation model for other cities, it's no problem. So, currently, our research focus lies on European cities, so that we say, okay, we just focus on European cities. But I think also the tool is usable for every city. It's as good data from, for example, OSM and so on. So I think the only issue is currently the data quality. So if you have data that's good for an area, then it's possible to calculate, of course.
Absolutely. And then that last sort of more open-ended question, and I think in a way you did answer it, but I thought I might come back to it just in case there's some more interesting news. And that is from Jan, and he asks, what are the plans for development of the plugin? So other than, of course,
Yeah,
what you had on your slide.
Yeah. So as I said, I think the most urgent one is to increase the performance of the tool to make it more better performing, and hopefully I find the time to develop it further end of this year to make it more performant and to make it more good looking. Currently, we have some issues that, for example, the ORS plugin changes. So we also have to look that our tool works when this plugin changes. So we do not have so much resources to develop it further. So it's mainly on my shoulders to have a look on it. And so we do our best and hope we can finish an alpha version beginning of next year to make it run better.
Absolutely. So it really is sort of the bleeding / cutting edge of the development of the application. And I think it's going to be great to watch over time where it goes and how it evolves. I always find that sort of thing really exciting. So if anyone else has any other questions, please pose them now, or else I'll start wrapping up this really, really cool session on walkability. I think my last question to you, Chris, is where did this kind of come from? So what was your first, like, who had the idea this is what we're going to need? I know, particularly in Europe, there's quite a movement towards, more walkable areas, car-free zones in cities. Was that generally like the spark that ignited making an application like this, or where did the base idea come from?
Yeah, I think it's a really great debate in Europe or in Germany also that, for example, ideas like the 50-minute city and so on, that you can everything within 50 minutes. I think it's a great idea behind it, and many also in our house in the ILS, there are many researchers who deals with walkability, and they ask, oh, can you calculate that for me, for example? And there was some kind of point where we said, okay, it's good. So many people need this stuff or need data sets or need such analysis that we said, okay, we could develop our own tool. We had also some great collaboration with TU Dublin and Lisbon, that we can say, okay, we have so much knowledge about the methodology behind calculating or assessing walkability that we could use them to develop our own tool. So it was just write down all the code stuff and hope that it works. And yeah, now we're at the point that hopefully it could get better. And yeah.
Brilliant stuff. All right, so I'm then going to wrap us up there, and it leaves me to thank you, Christian, for coming and giving us an amazing look into the tool that is being developed and does currently have a working version. And I hope that, early next year or in the next year, when the tool is up and running and all those, little kinks have been ironed out, you can come and give us a session just showing the updates and how awesome the tool is working. So thank you very much.
Yeah, thank you. Looking forward to it, and hopefully it will happen.
Fantastic. All right. Cheers, everyone. Please log in the next hour, top of the next hour, for the next session, and I will see you all there. Thank you.